Hi, I'm John, and this is my video about testing .NET applications. So in this video, I'm going to be giving a brief overview of testing of .NET applications. This video is going to be mainly focused on unit testing and integration testing as two key types of testing. But I'm also going to give a brief summary into some of the other types of tests that we see for .NET applications. So let's start by looking at unit testing. And unit testing is focused on testing individual components of code to ensure that they function in isolation. So this is stuff like classes, functions, methods. We're testing those individual units without dependencies on external infrastructure and just making sure that they execute and give us the response or the result that we have defined in the test. When we're running unit tests, we're testing new functionality or existing functionality. So typically we're going to have a collection of unit tests in a separate project within our solution. And as we're adding new functionality to our application, we're going to be adding new unit tests to test that functionality. So then when we're ready to commit our code, we'll then run all of the unit tests, including the new ones and the old ones for pre-existing functionality. And ultimately, this should give us confidence the changes we've made to the application work and are tested, but also the existing functionality that was working before continues to work and work as expected. Unit testing is typically implemented through testing frameworks that are available to be added to your projects, including MS Test, NUnit, and XUnit. And one of the things we can do with unit testing and integration testing as well, which we'll get to, is we can integrate these as a prerequisite in a pull request. So if we're using CI, CD pipelines and tooling, typically these tools provide us with a mechanism, whether it's through a branching policy or an automated process. Whenever we make a commit, we can have all of our unit tests run. And as long as they're small, which is one of the recommended practices, these tests should run very quickly, shouldn't delay delivery by too much, but give us confidence that when we're integrating our code and preparing for that deployment to production, that the components work as expected. So I'm going to go through some of the recommendations around good unit tests. So first, we've got timely. And this means the time that it takes to write the unit test. It should not take a disproportionate amount of time to write the unit test compared to writing the code that we're testing. And if we are in a scenario where we're finding ourselves writing very long unit tests that are taking hours to run, much longer than the time that it took to write the code itself, then we need to consider whether we need to change our code to make it more testable. We've then got self-checking, and this just means that the test should run and report a pass or fail without any human interaction. So we may have many tests, especially more mature projects. We could have thousands of tests, and we need them to run by themselves, report a pass or failure by themselves, so that we're not hanging up the delivery in the next stage of the deployment and work towards production. We then have repeatable, and repeatable means that the result of the unit test should be the same every time, unless we've changed the source code or the test itself. The output should be consistent, and this just makes the unit test reliable. We then have isolated, and this means that the unit test should not be depending on external services, infrastructure databases. It should be mocking or stubbing these objects, because otherwise the test can become quite slow and brittle. And since we're going to have a lot of these tests, we want them to run as quickly as possible. And that leads us on to the next one, which is fast. As I mentioned, because of the many thousands of unit tests that we could potentially have, we need the unit test to complete quickly and get a result fast, so we're not hanging up the next stages of the deployment and work towards production. And then another recommendation too is to use a well-defined naming convention. So By looking at the name of a unit test, we should be able to discern what it's testing, what is the expected result, and what a pass looks like. So we should have well named and a good naming convention for our unit tests. So the final element of unit testing is code coverage. So code coverage percentage indicates the amount of code that's covered by unit tests. So all of our methods, functions, modules, when we apply a unit test, Visual Studio will tell us what our code coverage percentage is, and it means how much of the code, how many of the nuances and the logic is covered by a unit test. And it shows good team maturity to have a high code coverage percentage, and we typically aim for about 90%. This can be a good insight into test quality, and it helps reduce risk and provide refactoring confidence. So when you've got that high code coverage number, you know that you've got a bit more confidence in your refactoring when all of the unit tests pass. With that being said, there is diminishing returns when going beyond a certain point. So as I mentioned, typically about 90% is a good goal for code coverage. As you start getting to those higher numbers, to between 90 and 100%, it starts to become harder and harder to cover all of the nuances, and there might be pieces of trivial code as well that requires a lot of effort to make sure it's covered by a unit test and not necessarily be valuable to us. So ultimately, about 90% and potentially diminishing returns if we aim much higher than that. So the next type of testing is integration testing, and these are similar to unit testing, but they are allowed to have dependencies, and that is actually the main purpose of integration testing, is to test integrations with external services and parts of the infrastructure at this point. So it does not typically mock or stub out the real implementations of integrated parts like what we would with unit tests. It may require a specific environment that mirrors production as closely as possible, and this just makes the integration test as accurate as possible, and that's going to give us more confidence knowing that we've done integration testing as against a like-for-like environment to production. And they are slower than unit tests, of course, because of those external dependencies. Unit tests, we're kind of aiming for them to really run in milliseconds, whereas integration testing are slower, and that's why we don't have those infrastructure dependencies as part of unit tests, because they're designed to be quick. Cool. So now I'm going to go through other types of testing that we typically see around .NET applications that you might want to consider. So we've got functional testing, and this focuses on the application's business requirements, and it ensures that the application works as per specified criteria. It can be a combination of real testers or code-driven tests that simulate user behavior. So this can be users logging in, carrying out for certain steps in the application and ensuring that the application works as expected. Of course, functional testing is going to take longer because we've got to engage users. The tester, the technical person that's dealing with the application, might not necessarily know what the steps are, so it means engaging people from the business to run these tests. So we can actually reduce the functional testing through unit tests. So there's a lot of tests we can do through unit tests that will mean less time functional testing. And then this can be integrated with CI/CD tooling as well to ensure application functionality stays intact as developers make changes. So the next type of test is system testing, and this is the complete and integrated software application is tested. It ensures that the end-to-end functioning of the software meets the specified requirements and focused on input and output rather than the internal workings of the application. Regression testing that ensures that newly added or modified code hasn't negatively affected existing functionality. Any test, including unit, integration, system, and other, can serve as a regression test. So this is not like distinct in the way that unit, integration, system is. Regression testing can fall into any of those categories. So what we might find is we've noticed a bug on the application. As we're trying to debug that issue, we end up by writing a unit test which reproduces the issue, and then that unit test permanently gets added to the application and then serves as a regression test. Then we have end-to-end testing, and this ensures the flow of an application's process is functioning as expected from start to finish. It validates the entire process of an application, ensuring that it's functioning smoothly. It tests the entire system and of integrated parts, databases, network services, and third-party interfaces. And there's some example tools here. We've got Selenium, which is a browser automation tool that allows tests to be written in C#. Playwright for .NET, which provides capabilities to automate browser interactions, and SpecFlow, which allows tests to be written in natural language. And the next type of test is performance testing, and this is testing your application under load. So determining responsiveness, throughput, and scalability of the system under given load. Ensuring applications can meet desired service levels and provide a good user experience. So this is a bit harder than a unit test, which is logical. It can run through a set of code. Has it got this particular result or not? Performance testing is a little bit harder. It's a bit more looking at a more realistic scenario in production, because what we test on our machine and what we're doing on our machine might work perfectly, but when the system's under load and it's not efficient, the application is not written efficiently, we're going to start to see issues. So some tools include Visual Studio Enterprise, which contains an integrated suite of testing tools, including web performance and load tests. Apache JMeter, an open source tool that can simulate loads on .NET applications, and Load Runner, a comprehensive performance testing tool that supports .NET applications. Then we've got security testing, and of course security is key to our application, and we should be thinking about security through all of these phases in the application lifecycle. So security testing as a category is aimed at discovering vulnerabilities, threats, and risks in a system. Ensures the safety of the application and establishing trust with the users. So examples include static code analysis. This might be with a solution such as SonarQube. Penetration testing, which would typically involve getting in a third party and doing a deep test against your application, maybe bombarding the application looking for vulnerabilities. And then dependency scanning, so the kind of NuGet packages you've got in your application, do they introduce any vulnerabilities into the application? And then finally, we've got usability testing, and this focuses on the user experience, ensuring that the application is user-friendly and intuitive. That concludes my presentation on unit testing, integration testing, and other testing types for .NET applications. Thank you for watching.